a new one. All right, so what we're covering is 3.1, and we're covering how to find the average rate of change. And like I said before, if I wanted to find the instantaneous rate of change, that's a calculus concept. But in order to know how to do the calculus, for those of you who are freshmen, you might actually get to that in your senior year. But let's do the average rate of change. An average rate of change is trying to figure out what is the average distance that you are rising compared to how far over you are running. Basically, if I want to know what the average is, I have to draw like a line between the 2 points. And I want to find that average rate of change. What is it? It's really the slope of this line between the 2 points. It may not be exactly the same as the curve, but it will give us the average between the 2 points. And so there's a very simple formula to find the average rate of change. It is, I'm going to show you where it comes from. Let's call this point here X and Y. And let's call this other point an X and Y. But since these are two different points, we got to classify them differently. This is not the same X as that one. So I'm going to call this one X1 and Y1. I put these little ones at the bottom, and all it's going to mean is that this is our first X and this is our first Y. And because these are X1 and Y1, this is going to be X2 and Y2. Those are called subscripts. Subscripts. And they are basically a way for us to tell them apart. It's the only thing that they're there for. This X is different than that X. This is our second X, that's our first X. This is our second Y, that's our first Y. That's all that means. And so if I want to know how much the average rate is changing, then what I need to know is I want to know how much is changing from this Y to this Y. Well, from here, let me just draw a little arrow. From the x-axis to this point is Y1. And then from the x-axis up to here is Y2. If I want to know how much this point is rising, what I have to do is I have to subtract Y2 minus Y1. I'm going to put that right here, Y2 minus Y1. It's the distance from this point, if I were to draw a triangle, to this point. I'm going to highlight it in red if I can. Here is the red piece. This is Y2 minus Y1. It's also known as the rise. And if X is the distance from here to here, X1, and this is the distance to X2, then this distance down here is known as X2 minus X1. It's also known as the run. The rise and the run. That is a super complicated way to say what we're going to find is the slope. The average rate of change is also known as the slope, which is equal to the rise over the run. In higher level math, we have a formula for the slope. And we use symbols sometimes in higher level math. And I'm going to show you a Greek letter. This is called the letter delta. It's a triangle shape. Delta y over delta x. Mr. Paramo taught us a Greek letter today called delta. Yes, I did. That's okay. It looks like a triangle. It's kind of like the alphabet, like the letter A has an uppercase and a lowercase. This is a lowercase delta. And what a lowercase delta means is the difference of. So I'm going to put that off to the side. This means the difference of. In case you want to know what the name of this is, it is a delta symbol. And what the rise is the change in y. If you see delta y, that means what's the change in y? I'm going to put the change of. And so there's a formula for what the slope is. It's the rise over the run, or the change in y over the change in x. And we can write it down. M is equal to y2 minus y1 over x2 minus x1. We're going to use this formula all the time. y2 minus y1 over x2 minus x1. And it doesn't matter if you have y2 first or x2 first, or this is the same thing as y1 minus y2 over x1 minus x2. As long as I have 1 over 1 first and 2 over 2 second, or 2 over 2 first and 1 over 1 second, then it is the same thing. I can use either formula. So I'm going to highlight this. I know we've been talking about highlighting our notes and underlining and revising things, but since we use this all the time, I'm going to highlight it because that's what this is an important formula for us to use. We're not going to just use it in section 1. We're going to be using it in section 1 and in section 2. I'm going to give you an example that looks like number 3. Number 3 has an example that looks like this. Hours, cars. And 1 hour, 2 hours, 3 hours, 4 hours. 4 cars, 8 cars, 12 cars, 16 cars. Let me adjust this real quick. The question is going to say, what is the average rate of change between hour 1 and hour 4? What is the average rate of change between hour 1 and hour 4? So what are they asking us to do? They're trying to say, okay, if this is your second point and this is your first point, what's the average rate of change? They're asking you to find the slope. Do you know which ones your y values are? Are your y values cars or hours? Good. And so if you're going to between hour 1 and hour 4, the first thing I like to do is kind of circle what I'm talking about. Between hour 1 and hour 4. You have a choice. We want to always do the change in y over the change in x's. So these are your y's. You can either do 4 minus 16 or 16 minus 4. Which one would you rather do?
16 minus 4.
Now, here's your warning. If you do 16 minus 4, if I do this bottom one subtracted by the top, you need to do the bottom one subtracted by the top for your x's. You need to do it in the same order. Same order. Matters. It matters, it matters, or same direction. Meaning if I do 16 minus 4, I have to do 4 minus 1. Otherwise it will be incorrect. That's why I like this delta y over delta x formula, because I'm doing the change in y. How much is it changing by for the y's over the change in x's? It's an easy way to remember it. Do you know what 16 minus 4 is? Do you know what 4 minus 1 is? And if you simplify it, you get 12 over 3. And what is 12 divided by 3? 4 is your average rate of change. Let's check and see if that makes sense. Is this average going up by 4 every single time? It is. It doesn't matter that I did between hours 1 and hours 4. That average rate of change is the same. And the reason it's the same is because this is a linear function. If it's linear, your graph is going to look something like this. Dot, 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 dot. And that rate of change is the same every single place you go. Even if you were to go up a lot and over a lot. That rate of change will reduce to the same thing. The first way you're going to have to do this is with a table and then given 2 points. You're going to have to figure out what the average rate of change is. The second way you're going to have to do it is with a graph. So let me give you an example of a graph like number 4. Let me adjust this up a little bit. Number 4 will look like a piece of graph paper. I'm going to label it 1 through 5. 5, 4, 3, 2, 1. 1, 2 for your x. I'll do 3 as well. 3, 4, 5. And it'll look something like this. What I tried to highlight here, there won't be any dots on your homework paper. It'll look more like this on your worksheet. Do you notice how there's no dots on this line? But I recommend if you're drawing something in your notes, we should probably know where it's crossing. Like this is the point 2, 5. So I put a dot there. So you know that it's at 2, 5. That the x is 2 and the y is 5. What else do I know? I know that this is going through the point 0, 1. So I'll label those points, even though on your worksheet it won't be labeled. And if I asked you to find the average rate of change, or if I asked you to find the slope, I'm asking you to find the same thing. So let's find the slope. So I'm hoping we know what to do. I'm curious if Riley knows what to do. Nope, he says. Okay, Riley, what we should be doing. Oh, let me ask Katie if she knows. Katie, what should we be doing? Oh, okay. You didn't know I was going to call on people. Yes, I am going to call on people. Katie, do you know what to do? Last person. All right, let's go back. Find the slope. How are we going to find the slope? We're going to use this simple formula. The one that we have highlighted. The one that says y2 minus y1 over x2 minus x1. It means we need to subtract our y values and divide it by subtracting our x values in the same direction. Let's go back to Riley. What does that mean, Riley? What are we going to do? He still doesn't understand. Katie, what does that mean we're going to do? Yeah, no, I think you're on the right track. Say it. Be brave. Okay, so what is, yes, you're going to subtract y's. What does that mean for this example? Good. I like what you're saying. You are exactly right. Cade, what are we going to do?
Subtract.
What are we going to subtract? Good. Riley, what are we going to do?
Subtract by 1.
Subtract what?
By 1.
By 1. What are we going to subtract by 1?
0.
No. Riley, you're not listening. We got to have you listen a little bit better. Okay. Katie, explain what we're doing. Katie, what are we doing again? We're subtracting 5 by 1. Now, Riley, do you know why we're subtracting 5 by 1? There's an easy answer for that. Why are we subtracting 5 minus 1? Doesn't know. Do you know, Michaela? I think she's close. Trinity, how come?
Because it's y2 minus y1, x2 minus x2.
Good explanation. I like it. I like it. A little bit clearer, right? That's what I like. Okay, we're doing the y's minus the y's. That's what it is. Riley, what are we going to do? What is over?
2 and 0.
Yeah, be more specific.
2 minus 0.
Thank you. Much better. I like that. And I think he knows why now. Like he saw it and was able to do it. Christian, help me finish this.
So 5 minus 1 is 4.
Okay?
And then 2 minus 0 is 2.
Keep going.
And then you get 2.
Good. If you want, you can put m is equal to 2. That's what the slope is. That's what your average rate of change is. I feel like when I called on you, you started to understand. Yes, that's what I want you to be able to do. And let me double check. Is the slope 2? Is it rising 2 and going over 1? Is it rising 2 and going over 1? I could double check that. It works. The first thing you have to do is from a table. The second thing you have to do is for a graph. Now, let me show you the trick questions for graphs. Let's talk about a trick question for graph. I'm going to put it over here. Trick. I'll move this over a little bit so it's centered. Trick questions. They're not tricky, but they're tricky enough that we need to talk about them. 1, 2, 1, 2. I'm going to draw a graph here, and I'm going to use a red pen so you can tell the difference, okay? Let's say I have a horizontal line. And I pick 2 points on this horizontal line. I'm going to pick 2 points here. I'm going to pick this point here and this point here. Because it doesn't matter what your 2 points are. And I'm going to label this point here. The x is what number and the y is what number? The x is what number? 0. Just said it right there. Thank you. And the y is what number?
2.
Good. Now let's label this point here. The x is what number?
0.
Nope. Good. What's the y?
2.
Good. So I have 0, 2, and 2, 2. If I were to do this, problem, and I were to do the same exact thing that we were doing before, this is what you would have. You would have this y2 minus this y2. 2 minus 2 over this x minus this x. And when I say the same direction, on ordered pairs, I have to do 2 minus 2 and 2 minus 0 because I have to do the y subtracted by a y and an x divided by subtracted by an x, and I go in the same direction. This is what I get. 2 minus 2, which is 0 over 2. You may not know if you can do this or not. 0 divided by 2. So I'm going to punch that into a calculator real quick. Just because. 0 divided by 2 is 0. The slope is equal to 0 for a horizontal line. Your slope is 0. That means you're rising nothing and going over as many as you want. Is that the same for a vertical line? Okay, this one was a horizontal line. Now we're going to do a vertical line. I'm going to do this vertical line here on 3. And then I'm going to pick a couple of points. I'll do this point and that point. Let's label some points. I'm hoping you know what this point is. Let me ask Natalie. Natalie, the point that I'm pointing to, what is the ordered pair? 3, 0. I like it. The other point that I'm pointing to, Blake, what is this point that I'm pointing to?
That
What?
would be 3, 3.
Yes, it is. And then what I'm going to do is I'm going to take the difference of y's and I'm going to put it over the difference of x's. The change in y over the change in x's. I have 3 minus 0 over 3 minus 3. 3 minus 0. 3 minus 3. Just together. Yep, and there's that if you want.
Okay.
If you're not sure if you can do that, you can take your calculator and watch what happens when I do 3 divided by 0 and I press equals. Ready? Here it goes. Equals. What this means is it doesn't exist. If you ever get syntax error or you get error or you get undefined, it means it does not exist. It means that the calculator does not have an answer for this particular question. It doesn't exist in its programming. What does that mean? That means that this is undefined. You can write undefined or you can write no slope. It doesn't exist. We're almost done. Hang in there, boys. I had a fellow teacher that told me an easy way to remember this. 0 on top is okay. 0 on bottom is no way. Okay? This is how this person reminded me, and I don't know if I can show it in the recording, so I'm going to do it live for you. If you put your thumbs down like this and your thumbs up like this, 0 on top is okay to have. You can have a slope of 0. 0 on bottom is no way. You cannot have a slope where you're dividing by 0. It's undefined. It doesn't exist. So if you're ever forgetting and you want to remember, putting your thumbs up, thumbs down, pounding on it like this is an easy way to remember. Let me try to show in the recording what that looks like. Thumbs up, thumbs down. 0 on bottom, no way. I don't know if that looks too good on the recording, huh? Hey. It's helpful in real life. That's just kind of zoomed in on some things. I don't know. I can't draw the thumbs up and thumbs down. No, we're good. Okay. Last one, and I want to do like number 14. Last one. Hang in there, hang in there. Okay? So, let me recap what we've done. How do we find the average rate of change? We find it by using this simple formula, the change in y over the change in x. Okay, I showed you where it comes from, which is way more advanced than probably anybody has shown you so far, but because I teach calculus, I like to show that. Yes, you have to be able to take a table to find the average rate of change. You have to be able to take a graph and find the average rate of change, including trick questions. And the last thing you have to do, what if there's no graph and no table? What if you have 2 points and you have to find the average rate of change? And there's going to be negatives thrown in there. Let's do this one together. You're going to have to make a choice. What I recommend you do is this. Let's call this. Is this x or is this y, the 8? I like to put an x over the 8. What's the negative 4, x or y? What about the negative 6? What about the negative 3? So this is an x, that's a y. This is an x, that's a y. Since they're different x's, we should probably label this as your first x, your first y, your second x, your second y. That way you get to decide what's going to subtract it by what. Do you want to do negative 4 minus negative 3, or do you want to do negative 3 minus negative 4? Now here's the deal. Whatever you decide, be careful with your negatives, and you're subtracting a negative. So let me say I go this way this time, okay? I'm going to write negative 4 first. That's my y. And then I'm going to subtract. What do I have to subtract? Negative 4 minus what?
Minus negative 3.
So put it like this. You're going to subtract a negative 3. This by far is a most missed question. I'm going to put a star next to it. Why do I put a star? Because it's very common that people forget you're subtracting the negative 3. Don't forget you're subtracting negative 3. You're doing the opposite of a negative 3. What is the opposite of a negative 3? Change those to positives, please. Negative times a negative is a positive. Over. I did this way, so now I have to do this way. 8 minus, what am I subtracting?
Negative 6.
Don't forget you're subtracting a negative. You're doing the opposite of a negative. Negative times a negative is a positive. And then you simplify. Negative 4 plus 3?
1.
Close.
Negative 1.
8 plus 6?
13.
Negative 1 divided by 14. That is all you can do. That is your average rate of change.